Okay, so you have to ask yourself, is there a metal? Okay, is there a metal? And if you do have a metal, then what do we know we have? What kind of compound is that? That is an ionic compound, right? So it's ionic versus covalent, and we're asking ourselves because we want to know if it's ionic. All right, covalent we'll deal with later. Prefixes, yes. All right, so once we know that we have an ionic compound, we know that we are probably going to be ending with "ide." Okay, and you'll get a little bit more practice with that today. So you are most likely ending with "ide" unless we have what at the end of our compound? Right, kind of like oxygen. It's something that involves oxygen. Starts with a P, ends with polyatomic. Polyatomic, you got it. Polyatomic ions, right? And those ends with eights and ites. Okay, so that's the only exception. Otherwise, all your ionic stuff ends with "ide." Okay? All right, so once we know that we have a metal, and we're looking at the first item in that compound, okay, and there is a metal, what's the next question that you have to ask yourself before you go and name it?
Where's it at?
I don't know if, I feel like someone was trying to say it, but is it a transition metal? Yes. Okay. I think somebody said multiple something.
I just said it there. So I was
Because you could say multiple charges, and that would be true. All right, so transition metal. Most of those guys have multiple charges, so you always have to figure them out because you have to say which one you're talking about. So there's like copper 1, copper 2, right? Nickel 1 and 2, iron 2 and 3, those things, okay? So how are we going to represent those in the names? Like, why do we even care about recognizing a transition metal? What has to be included in the name? Romans. That's great. Sorry, I was making sure. Sorry, I think I said nickel 1 and 2. It's actually nickel 2 and 3. I just wanted to be accurate. Sorry, my bad. I made that mistake. All right, anyway. So once we've realized that we have a transition metal or we don't have a transition metal, we're done with the metal. Now what do we ask ourselves? What are we looking at before we name it?
charge.
Come on, we already said it one time, you guys. Is there a polyatomic? Okay, and I wrote that one in purple so that you recognize that we're not talking about the metal anymore. We're talking about the second part of the compound. Okay, where are we gonna find our polyatomic ions? Where are we gonna be looking?
And on the inside of the periodic table
Yep.
on the list.
Yep, your periodic table list. And worst case scenario, if you cannot find it on there, if it's another one, I do have an extended list up here, covers both sides. If it's not on this one, you can also Google it. Because basically all the ones that are in your periodic table, each one of those have 4 different versions of them. So yeah, it's fun. It's fun stuff. Join AP chemistry. Yes. All right. By the way, how are we going to recognize these polyatomic ions? What are we looking for? Like what will kind of be a red flag? Oxygens, right? We want some oxygens in there. So I'm just going to write that right here. So oxygens with an element. So with another element, basically, is what I'm trying to say. All right? So an example of that, just so you know what isn't and what is, if I have something like, here we go, K2O, is there an oxygen there?
Yes.
Does that make it a polyatomic?
Yes.
No.
Why not?
No. Because when you ask yourself the questions, is there a metal? Yep. Is it a transition metal? Nope. But we've already dealt with the metal. We're not paying attention to that first thing listed anymore. We are only looking at this. Is that attached to anything?
No.
It is by itself. It's just an oxide. Okay? Okay. An example of one with a polyatomic would be something like this. Yeah, okay. So once again, is there a metal? Yep. Is it transition? Nope. But we're done talking about it. Is there oxygen?
Yes.
Is it hooked up with something?
Yes.
Yes, that's a polyatomic. And how can you verify it? Because you won't know them all from the start. Where are you going to look? In your periodic table. So basically you're like, that one might be a polyatomic. Then I would go to my periodic table and I would double check. If it shows up on the list, hey, that's fair game. Okay? Do you guys see that? Okay, so back onto this. Okay, we're going to do those 3 compounds. We're going to practice naming them, and then just like I promised, we'll do one with the polyatomic. Okay, so we'll throw one more in there. So we're just going to run through those questions. Okay, we'll make this as quick as possible so that you guys get more practice on your own. So the first example that I have up here is SRBR2. Okay, SRBR2. Is there a metal?
No. Yes.
Look at your periodic table. Where should you be looking on your periodic table? To the left or to the right?
Right.
To the left. Okay. Let's regroup for a second. Is there a metal? Yes. Yes, there is something to the left of the periodic table. Do you guys see that? Strontium. Okay, so we paid attention to the first guy only. It is a metal. Is it a transition metal? No, that's when you should be looking at the D sublevel. So it's not in the center. So we don't have to worry about Roman numerals. We're going to write out strontium. We're done with the metal. Now we're going to ask ourselves that last question. Is there a polyatomic ion? Are there awkward oxygens with an extra element shoved in there? No. So we're just going to name it as is using the "ide" ending. So we're going to have bromine. And instead of bromine, we're going to take that part out and say bromide. Good?
No, I have a question.
Okay, so our next example. Let's go to, I guess I have to read it to me. It's off my screen. Sorry. Oh, RB. Thank you. RB3PO4. Okay. I'm not going to put parentheses because that's not how it would show up typically. But you guys should definitely add them in once you recognize you have a polyatomic. All right. So is there a metal?
Yes.
Who's the metal?
Who said oxygen?
This is why I'm asking. Who's the metal? Rubidium. Okay. Is rubidium a transition metal? No, because it's in group what, Leora?
Uno.
Yeah. Good. All right. So we're going to just go ahead and write out the name, rubidium, because we don't have to worry about finding Roman numerals, right? We're done with the metal. Let's focus on the non-metal part, or the second part, okay? Okay, are there a bunch of oxygens?
Yes.
Are they linked to some extra element in there?
Yes.
Yes. So is it a polyatomic?
Yes.
All right, so where are you going to look? In the periodic table. Go find it. Go find PO4.
PO4.
Good. Down at the bottom. Down at the bottom.
Wait, what makes it a polyatomic? If they get next to another, it's about
PO4.
All right, so our last example that was up there, and then we'll do one more after, was Ni3N2. Is there a metal?
Yes.
Yes. Who is it?
Nickel.
Nickel. Good. Is nickel a transition metal?
Yes.
Yes. So we have to stop there because we can't just continue on. We know that we have nickel, but we need to know what the Roman numeral is going to be, right? So I shouldn't have wrote right there. There we go. All right. So if we don't know what nickel's charge is, because that's what we're trying to find, which charge do we know? It should be nitrogen. Look at your periodic table. Let's figure out what it is. He's in group 15. Just heads up. Okay, remember, those charges come from how far away they are from being a noble gas. 3. They're 3 spots away, 3 jumps away, right? So what I'm going to do just to kind of help myself out and help my eyes out is I'm going to put it in parentheses like that, just so I'm only focused on the nitrogen. That's the only reason I did that. Does it need parentheses? Absolutely not. All right. So nitrogen has a -3 charge. But how many of them are there? There are 2. So therefore, what is the total negative charge in this thing? There's -6. They need, this whole compound needs stability. It needs to balance out to what number?
8.
I shouldn't have said balance, but it needs, no, what's the charge? What do you want your charges to be? 0, right? Noble gases have a 0 charge, right? They're stable, right? Thank you. All right. So your compounds bond so that they can be stable, right? So we want that overall overall 0 charge, okay? So if I have a -6 right here, what do I need the positive charge to equal out to be? A +6. But we have to respect the fact that there is not just one of those. How many of them are there?
3.
There are 3. So we're going to say 6 divided by 3 means each nickel has what charge? A +2 charge. Therefore, that's what goes for my Roman numerals. Roman numeral 2. And then how would we end this? Is there a polyatomic?
No.
Nope. So we just name it with an "ide." Yep. Nitride. And I tried really hard on this. Ah. I know. I know. Okay. So, I was going to do one with the polyatomic, and maybe it'll clear it up. Do you guys want to try that and then see if you still have the question? So with nickel, and then we have SO4, right? So we already know it's a transition metal. We got to figure out that Roman numeral. Okay, we've already asked those 2 questions. Okay, so looking at this, you say, ooh, there's oxygens. There's an extra element. I'm going to go check my polyatomic list and see what we're talking about here. So everybody find it on your list. I know a few of you guys already have. That's good. You should be finding sulfate. You should be seeing SO4. Okay, so you guys see that. So we already know we're going to be ending with, oh, I shouldn't write that. We're going to be ending with sulfate. So that's cool. But what other piece of information is with that?
There's 4.
A -2 charge. Do you guys see that on it?
Whoa.
Do you see it on your list? They're really tiny up in the corner. Okay. All right. So it has a -2 charge, the whole ion right there. Okay. So, hey, if you wrote it right there, you should write it on the outside so you don't get too confused. Sorry. Okay. So we have a -2. How many sulfates are there? There's only 1. There's no little subscript outside the parentheses. Okay? So there's only 1. So overall, what's that charge? A -2.
You haven't learned it yet.
Okay? Okay. So if we have a -2, what has to balance it out? What? There is no -1.
I mean the -1, the 1 right there. You said the bottom.
Because there was nothing there, so I'm helping you out by saying that if there's not a number there, it's a 1. So there's only 1 sulfate ion. Do you see that?
1 sulfate ion.
You have to. It's not oxygen, right? It's sulfate.
So 1 sulfate.
No, I wasn't trying to. I'm just. But that was a question from last period too. Do you guys understand? Polyatomic ions are a thing. Like they stay together. They are not oxygen and sulfur. It is a sulfate. That's it. So sulfate is defined with 4 oxygens. That's it. Because if you look at it, sulfite is 3. Okay? So this number is telling you what it is. It's telling you what it is. Yeah. Okay? Okay. Okay, so how many sulfate ions are evident up there? One. If there was a 3 right here, how many of them are there?
3.
Good, okay. All right, so we only have 1. So, since there's only 1, we have an overall of -2 charge. We know that the whole compound has to equal 0, so what has to balance that out? A +2. And we have to respect how many nitrogens there. Nitrogens. Yeah, the other end. How many nickels there are, right? So there's only 1 nickel.
Anything but one itself, so
So you're going to do 2 divided by 1 equals a what charge?
a 2, so it's nickel 2.
So we have a +2. So now you end with nickel, Roman numeral 2, sulfate, yes?
But I still don't get how.
Here are 2 of the examples from the little half sheet that we're taping into your journal. So these are the 2 examples. You can pause the video and kind of look through the process and watch the previous video, which kind of shows you where these are even coming from. So you get your valence electrons, put the dots around them, and then you put things into brackets and end with their charge, and then those give you the formulas after counting.